All right, so now we're going to use our so-called TOA. In fact, I'm going to write it right here to help us remember all this lovely stuff. We're going to use that SOHCAHTOA TOA that we just learned to help us to find trig ratios for this angle theta. Here's my theta. So very first thing you want to do is label your triangle. Okay, again, I look at my right angle, go across from that, and I'm going to label my hypotenuse very first. Okay, then wherever theta is, you go opposite that or across from that. That's your opposite side. So that leaves this 5 as my adjacent. All right, now first thing you might notice, especially when we go to do our sign that uses the opposite over the hypotenuse, is we do not have a value for the hypotenuse. However, because this is a right triangle, we can find a missing side of our right triangle. So remember Pythagorean theorem, a squared plus b squared is equal to c squared. You just have to remember c has to be your hypotenuse. Okay, so when we're finding this, it really doesn't matter which one here is a and b. Plug the 12 in for a if you'd like. Plug the 5 in for b. But you're going to have to use that hypotenuse as your c squared. Okay, so we're going to go ahead and solve this. 12 squared is 144. 5 squared is 25. When I add those together, 144 plus 25, I've got 169 as my c squared. Take the square root of both sides, and c here is equal to 13. So we're going to just write a nice, lovely 13 right there. All right, now we're ready to go. Now we're just going to look up here. I'm going to make this in red right here. At our SOHCAHTOA TOA, this honestly just tells us everything we need to do. So we know that the sine right here is of my angle is equal to the opposite over the hypotenuse. So I find which side I labeled the opposite, 12, and I'm going to divide it by my hypotenuse, 13, and that's it. Okay, look at the cosine. The cosine here is the adjacent over the hypotenuse. So look, we said 5 here was my adjacent over that hypotenuse, which is 13. And then the tangent is equal to the opposite over the adjacent, or 12 over 5. Okay, and then the reciprocal functions, nice and easy. We're just going to switch places. So 13 over 12 instead of 12 over 13. This 5 over 13 switches to 13 over 5, and the 12 over 5 switches to 5 over 12. And we're done. All right, let's look at this last example. The only difference here is they did not draw a triangle. So we're going to draw our own triangle. Just make sure it's a right triangle, but other than that, it really doesn't, you don't have to draw it to scale or anything. So what they've given us here, looking at this SOHCAHTOA TOA, they've given us the cosine. So they've given us actually two sides of our triangle. They've given us the adjacent. See how the cosine is the adjacent over the hypotenuse. So they've given us the adjacent side over the hypotenuse. So however you draw this, like you could put theta anywhere you want it. So if we just want to put theta up here, we're going to label our triangle. So when we go through here, I again find that right angle, go across from it. There's my hypotenuse. Across from theta is my opposite. That leaves this last side to be the adjacent. And we just plug in some numbers. So 2, here's my adjacent. 3 is my hypotenuse. And then we're missing this side. So we can solve for that just like we did over here using our Pythagorean theorem. Just watch out. This time we know the hypotenuse. Okay, so when we plug in numbers, we're missing an A or a B. Okay, so if you want, just put that 2 in as your A. We'll just leave this opposite as B squared is equal to 3 squared. So just always make sure that whatever is labeled as your hypotenuse is your C. The other two could be either one. So we've got a 4 plus b squared is equal to 9 right here. So now when I'm solving for b squared, over here I just had c squared by itself. I've got to get b squared by itself, so we're going to subtract 4 from both sides. B squared is equal to 5. Then we could just take the square root of both sides. And go ahead and just leave it. Don't put it into your calculator. So many people are doing that. Do not put it into your calculator. I just want to left there as the square root of 5. Okay, perfectly acceptable. It's the exact answer. We did not round it. All right, now we're just going to go through and plug in our values. So the sign here, again, we look at our SOHCAHTOA. The sign is the opposite over the hypotenuse. Okay, my opposite was the square root of 5. My hypotenuse is 3. And we're done. Okay, the cosine they already gave to us, the adjacent over the hypotenuse. The tangent here is the opposite over the adjacent. So my opposite is that square root of 5 over my adjacent, which is 2. All right, so now when we go through, when we flip these, that square root of 5 over 3 is going to turn into 3 over the square root of 5. Now, there is a rule in math. It came about a long time ago, and it's kind of slowly going away, but it's still a good rule, especially when we get into our next unit. We're going to have to use this. So we're going to teach it to you right now. But if you've got a radical on the bottom, you cannot leave it there. So this is not a good answer to circle, but it's really easy to fix. All you're going to do, instead of squaring it, remember, if you square something, you've got to square the other side, and then you've got it all messed up. So don't square it. But another way of thinking of squaring something is just timesing it by itself. So if I times this by 1, I don't change the value. So you're just going to look at whatever radical is in the denominator and multiply both the top and the bottom by that same radical. Because anything divided by itself is 1, so I'm not changing the value. But now I've got 3 times the square root of 5. And if you'll remember from last year, you can't multiply out of a radical with under a radical, so that just stays 3 times the square root of 5. But since these are both under a radical here, square root of 5 times square root of 5, that turns into the square root of 25. You can multiply things under a radical together. Okay, and we know what the square root of 25 is. What is the square root of 25? Yes, that is just plain 5. Okay, really, so whatever you multiply the root of by itself, it's just going to undo that root right there. So we've got a 3 square roots of 5 over 5 here. Secant, when we flip the cosine, there's no radical on the bottom, so we just leave that. That's it. Cotangent, we're going to have to do the same thing, because when we flip this, 2 goes to the top, square root of 5 in the denominator. But again, just multiply by the square root of 5 over square root of 5. Not too tricky. So I've got 2 square roots of 5, all divided by square root of 25, which is just 5. All right. Okay, there's only 4 questions on the homework. Good luck.